Okay, everybody, I posted the link to Facebook, and I also posted it to the old pre-scheduled live stream. So we'll just give people maybe a couple minutes to join here, and then we'll start.
Okay. You can hear me? Testing?
Yeah, we're live on this link. I
Perfect.
think we'll just give people a couple minutes to
Yeah.
join this new link. I posted it on Facebook.
Okay.
Um,
Hello, McDowell. Hello, 3DHP, Cutting Edge. Donnie, hello. Kenneth Sims, you're there also. We got Scott. Hello. Hello back. We got some interesting findings for you guys. This will be very, very intuitive for all of you. Just going to give a couple of more minutes for people to jump on a board because we had some technical issues and we weren't actually going live on time at 8 p.m. So we are live now. And just give people a chance to refresh themselves because the messages are coming in through Facebook that no one can find the link. So, anyway, you want to start up, Leo?
yeah, I'm just gonna post the link again on Facebook. All right, I think we can start.
Sure. Hello, Claire.
Okay, so this live stream is going to be about doing camera calibration on the LaserMATIC10. We chose the YouTube format because I think last time Zoom didn't work very well for a lot of people. So now everybody can see the same screen, and we got a little bit of an agenda, and when we have a small presentation, just a few slides to go over. So the flip side of that is when people are asking questions, it'll have to be by text in the chat towards the end there. So let's just get started. I'll go over the agenda real quickly. The first thing we're going to talk about is a typical result that people can expect. So I think we should be upfront in that the camera is not going to be perfect. So we'll go over what results people can expect. We'll go over importing the camera settings and a slightly different process than what was laid out in the user manual. And then Dimitri will do an actual demo of the calibration process, importing the files and also doing the alignment calibration. And I'll talk a little bit about lens calibration and why it's not recommended, but some people are curious about that process, so we'll go over that as well. And lastly, we'll talk about a few common pitfalls when setting up the camera, mostly to do with when people plug in the camera and they see nothing at all, or they see a black screen. So we'll talk about those issues as well. And finally, Q&A if people have questions. So yeah, I'm gonna add this slide here. Typical results that we can expect. Again, like I said, the camera is not going to be perfect. With a good calibration, if done properly, you can expect to be within about a millimeter So what does that look like? I'm gonna go over that now. So you guys probably have seen this pattern before. It's the 4 crosshairs when you're doing camera alignment calibration. So we do the 4 crosshairs here. That's the first step. And then we scramble the pieces of wood. We do the alignment calibration on smaller pieces of wood placed at the corners. So we scramble them around into random positions, and then we try to engrave concentric circles around the first calibration crosshairs. And that kind of tells us how far we're off by. It's a check you can do right after doing the camera alignment calibration. So what results do we get when we do this test? So the first one, the number 2, is, I think, can be considered a great result. You can see it's visually, it's almost completely concentric. So you're probably going to get this at around the center of your work table, and also maybe in certain areas, but typically not across the whole work table. The number 1 is a more typical result and is what I would consider acceptable. So if you look at the circle next to the number 1 there, it's off by maybe 0.7, 0.8 of a millimeter when I actually measured it. So 1 millimeter doesn't sound like much, but when you're trying to line things up exactly, you definitely can visually tell the difference. So if it's very critical, if it's a very critical job, you want to make sure you're working in the part of the work table, part of the honeycomb table that the camera is going to perform really well, or you should use a jig that can be positioned and secured at a known position. So that's kind of the setting expectations there. And if you get a result like this is something we can improve today. So if you're getting a result like this after this session with the learnings, you should be able to get a better result. Okay, so that's the first part. We want to set expectations. Next, I want to talk about importing the camera settings. Now this is where I may have been giving people not the best advice in terms of troubleshooting. So a common situation that people find themselves in is a situation like this. So when you update overlay in Lightburn, you want to check, the first thing you want to check is whether the image is still warped. If the edges of your honeycomb table is straight, or if it's still bowed out slightly. So in this situation, it is bowed out slightly. So you're not going to get a good result with this. Now, what I've been telling people, and this is the mistake I've made before, is when you're getting a result like this, just re-import the machine definitions in Lightburn. Now, there are 2 issues with this. I should probably share my screen here. Lightburn. Okay. Okay, so I'm here in Lightburn, and you can see that the edges of my honeycomb table is bowed out like this. Now, what I've been telling people is just, you got to go into devices, and you have to remove the Rode LaserMATIC and re-import the machine definitions. Now, there's 2 problems with this. One is it wipes your machine settings. So people typically like to set up Lightburn to their preferences, and then have to start over. But also it doesn't really work. So now if I have a setting like this, if I go and remove Rode LaserMATIC10 and add it back in, what we're going to find is that the camera image is still going to be bowed. So perhaps that's definitely my mistake for giving people that advice. But the more reliable way to do it, and easier, is, and I just found this out last week also, is you can right click on the camera control panel. So in Lightburn, you have these move panels, custom layers, and you can bring up the camera control panel. And if you right click on the camera control panel, you have options to export and import your camera settings. So in the Facebook group, I posted our camera settings just as a separate file, not together with, not together with adding devices here, but rather just settings for the camera. So if I import camera settings now, it should be lens profile, LaserMATIC. How come I cannot import? Yeah, if I import this camera setting here and I update overlay again, you'll see that the edges of the honeycomb table are now straight, right? And that the pieces of wood also appear straight around the corners. So that's a good sign. You want to see straight edges before you move on to alignment calibration. And if you don't see straight edges, just download the file from our Facebook group, and then go into Lightburn, right click on the camera control panel, and then import the camera settings. And that should be a good starting point. And you no longer have to, delete and re-add the Rollei LaserMATIC10 and resetting everything. So that's just importing the camera settings. But now, once you have imported the camera settings, you have to do the alignment calibration. So I'm gonna hand over that part to Dimitri. I'll remove my screen. Okay, you're good to go, Dimitri.
Perfect. Hello, members. And Leo forgot to mention that we have to also in camera. Okay, oh, that's why. There we go. In camera control, once we import the setting, we've got to save the setting as well. So click on save, and that way we have the setting. So what I'm going to do right now, can they see? They can't see the drop boxes, eh, Leo? No, they're not able to see our drop boxes. Yeah, some people commented already about that. We'll figure that out eventually. So basically my calibration right now is already preset. As you see, all my squares are, my alignment is all straight on my honeycomb. And so we're going to do the alignment. And we're using the HDR camera. Next. Now I got 3mm wood placed already. I'm going to jump this up to 9,000 because we don't want to waste your time. And 100%. I think Leo has a couple of things to mention as I, oops. Let me go over here a second. Just want to show the laser. Screen settings. There we go. Sorry about this, guys. And there we go. So I'll show the laser right now. And I'm going to do the framing. And notice over here, I'm using 182 scale for our corners. So I'm going to go ahead and start this. So while it's working, Leo, I think we got 3 minutes for a little bit of news.
Yeah, I was going to talk about kind of the release plans for the 20 watts. But since people mentioned in chat they couldn't see the boxes, I think I know the reason. So I'm just going to go back to my window and then try to do that instead. Let me see. Okay, so now I'm sharing my entire screen. When I'm in Lightburn, this is what I was talking about. In camera control panel, if you right click, you see this menu come up. Dimitri, can you see it now?
Yeah.
On your...
Yeah.
Okay, all right, that's cool. So this is where we click import camera settings, and then we come to select the file that we posted in Facebook, and then we update overlay. It's going to be straight. So just to go back the other way, to show people, if we import camera settings, and then we choose the profile that was done poorly on purpose, I suppose. If we update overlay, you'll see that we get the honeycomb edges bowed outward. And like Dimitri mentioned, once you have imported your camera settings, you update overlay, and then you do your alignment calibration, you gotta be sure to click on Save Settings, so that next time when you import, it's already got that calibration that you have done. So yeah, just now this menu wasn't showing up, so I just wanted to go over that again. Remove.
And we should be finishing up very shortly.
Okay.
Sorry for the smoke, guys. If you see it in the screen, I don't have my venting presently activated because my impeller makes a lot of noise at 85 decibels. So it's a little bit deafening on the mic. Actually, I can turn off my mic. How does that sound? Give me a sec.
Mike is asking, is the file available anywhere else? I do not use Facebook. Yeah, we can, if you email me, I can send you a copy, and I can also upload it to our website.
Alrighty then. So that's all done. And camera. There we go. So we're all done with that. So our next, capture image. And now we enter our little marks. And we click on finish. And now we want to save our settings at the same time. So this way now they're in there and we can get to export our settings. As you see, export camera settings right now since we saved them. And we click in a new name, basically test. As you see on my screen, everything I've already calibrated for all different types of thicknesses in 3 millimeter ratios. And that's it. So whenever you want to bring in a specific thickness of board or material, we just go in and we decide which material thickness we're actually calibrating, actually engraving on. And by doing so, your accuracy will become much greater. You'll have less chance of error. And at 1 millimeter, it's very, very good from what I understand. In fact, let me show this. Should I show them the soccer player?
Yeah, go ahead.
So this is the soccer player. So this was engraved at 0, and then I went diagonally to the opposite corner of the grid, overlapped the image, and we're talking this was off by 0.1, 0.2 millimeter. So that's 0.1 or 0.2 millimeter off. So I'm pretty sure if I played with the camera a little bit, I played with my mouse a little bit further, I may even haven't gotten it perfect. So it's very accurate. It's very accurate. But again, it all depends how you align your crosshairs to get that accuracy bang on.
Do you want to try the test now and
Let's
see
do a test. Yeah,
what
sure.
we get? Yeah.
Okay. Let me switch cameras.
Yeah, I think we might have gotten a little bit lucky last time. Yeah.
Okay. Find the board. Here we go. Alrighty. So let's home it.
So while you're doing that, I'm going through the chat. And Laszlo said you're making a different profile for each thickness. Yeah, like Dimitri was just saying, if you calibrate on, let's say, a 1/4 inch piece of wood, and then now you have a job for 1/2 inch, that calibration result is going to be off by a lot if you're using a different thickness material. So what you have to do is you gotta then calibrate again using a 1/2 inch material and then save that as a separate file. So you can name them like Dimitri is doing here, just by the thickness of the material. So then when you have the 1/2 inch job, you load the 1/2 inch calibration result. So for every thickness that you commonly would use the camera for, you have to have a calibration file.
Okay, so now I'm going to run it. Yeah, okay. This shouldn't take long. Oh, I'm doing a fill. Ah, man. Hold on a second, guys. I made a mistake.
Yeah, I do that all the time too, because the alignment calibration file is in fill mode. So then when you do something right after, it stays in fill mode.
Okay.
Like for example, if you want to test with the concentric circles, you want to switch to line mode right afterwards.
Okay.
Kenny is asking, so the camera is that sensitive? Well, it's not really the camera being sensitive, more just 1/2 inch. Sorry, in my prior example, like 1/4 inch, 1/2 inch. A difference of a 1/4 inch, it's a lot, right? Because the camera has a 90-degree view angle. So if you're a 1/4 inch closer to the camera, you're a 1/4 inch, sorry, more towards the center or more outward. But it's a big difference.
So that's the engraving. And now I'm going to put it all the way down here. So we started off at 0, 0. And now we're going to take the opposite corner. There we go. And we're going to bring our image so let's shift. Is that control or shift? Control.
I think it's control, yeah. So when you're dragging a shape, if you press Control in Lightburn, that will stop it from snapping to the grid. So then you're able to line it up with the pixels more precisely. Yeah, that's a small tip.
I think I'm pretty on.
Okay,
All right.
all right. Let's see it.
Let's see this
I'm a
now.
little nervous.
Okay. Now home the laser. Okay. And let's start it up. Yeah. That's a little bit off. That's a little bit way off.
Oh.
Yeah.
How much are we off by?
We're off by quite a bit. I don't think I used the right settings. Yeah.
I see.
Yeah. Let me try this again.
Mm-hmm.
Because I'm pretty sure I used the wrong settings.
I think you then have to calibrate the camera again.
Yeah. Well, no, I already have it. I already have my setting already in there.
Oh wait, did you use 3mm or test?
3mm. I didn't. I used over here. This one over here, which is the wrong one.
Right. Yeah.
319.
Exactly. I think because we were just doing test, then like test would be more accurate then.
Yeah, but I didn't really use my crosshairs to be accurate.
Oh, I see. So when you were clicking on the, I see. I think in that case, like we would probably have to calibrate again.
Give me a second.
Yeah. Okay.
Port.
So I think I know what the situation is.
Okay, let me try with the test. And
yeah,
let's bring it up here. All right. And let's start it up.
okay. I'm gonna look at the chat again.
Go. And let's do another overlay.
Mm-hmm.
Okay. I think I got it. Yeah, I think I got it. Okay. So little frame. And start again. Yeah. Much better result.
Yeah.
Okay, so the difference here is basically 0.2 millimeter offset.
Okay. Wait, I think Dimitri got disconnected. I think Dimitri is gonna come back soon.
Oh, okay.
Okay, you're back.
Okay.
Yeah. Can you switch the camera?
Perfect.
Okay. Yeah. Yeah. That's really good.
Yeah. So we're talking 0.2 millimeter basically.
Yeah, not as good as last time, but still a really good result, I would say.
Yeah, I'd say.
Yeah.
Compared to this one that we did yesterday.
Yeah, that one's pretty bang on. I think we got lucky with that one.
Yeah.
Yeah.
So those are the results, guys. I mean, pretty good, a lot better than before, that's for sure.
Yeah, I think so. I think what happened was because I'm looking, I'm remembering your like folder with all the calibration files. So I sent you the file named 3mm,
That's
and
correct.
that one was calibrated on my machine, so it has the right lens profile. But when you loaded it, and then because it didn't have the alignment calibration from your machine, then it's going to be off by quite a bit.
Yeah.
So that's what people would get if they just download the file and not do an alignment calibration. So I guess the lesson or the message is the lens calibration file is pretty good, but once you download it and you import it into Lightburn, you still have to do your own alignment calibration, and then yeah, save it to your own calibration file. So that's that. I think we can move on.
Yep, let's do.
Okay. So oh, I just realized I haven't been.
Did you answer Laszlo?
Yeah, I did. Yeah.
Okay.
So now we can talk about the lens calibration. This is not really recommended, to be honest. I can switch to my screen again. All right. So, but people have been asking, so I think I'm gonna go over it really quickly. With our lens profile and a good alignment calibration, usually you're able to get to the within 1mm we talked about at the beginning of the live stream. But if you're not getting that result, then maybe you have to do a lens calibration. It's very uncommon. I don't recommend it. But if you do have to do a lens calibration, you come to Laser Tools, Calibrate Camera Lens. This is where I differ a little bit from Richard's video when he initially reviewed the LaserMATIC10. So you select the appropriate camera, the HDR camera, and then fisheye lens. But instead of selecting one of the presets, you gotta select none and then do full calibration. Okay, so I'm gonna click next, and I think people are familiar with this, the polka dots pattern. But the important thing is you actually can't put the pattern on the laser bed, not with a fisheye lens. You can do that with a standard lens, but with a fisheye lens, you got to lift up the camera and then hold a piece. I'll show you. I got it prepared over here. So you got to hold something like this to the camera by hand. Okay. Okay. I'm gonna switch. So you got to make sure it's the printed out polka dot pattern is it's taped to a flat surface. So here I have an aluminum panel, and then next what you have to do is I gotta make sure it's the right side up. I think. So you got to lift up your camera, and then you have to hold it to the camera like this. I know it seems a bit counterintuitive because now you're losing reference to the workbed, but because the lens calibration is something that's completely intrinsic to the camera, it actually doesn't matter what the camera is looking at. You're just trying to get, as I move to the corners, you can see it's getting a little bit warped. So you're just trying to capture the intrinsic quality of the camera, basically. So I might not be able to finish it here. It's going to probably take way too long. But you hold it to the camera, and then you click capture. So here I got a score of 0.36. Now that's not good enough. It says you should get a result of 0.3 or less, but anything below 1 is accepted. I would strongly recommend getting a result that's at least 0.2. So we can play around with it a little bit here, but it is a test of patience. Okay, 0.07. That's a great result. Now, it doesn't really matter that the image inside this black square here doesn't make sense. We just have to trust Lightburn that, is satisfied with the results, so we're going to move on. And then we click next. Now, you got to know the camera is inverted in this position, right? So when it wants an image on the bottom, you actually got to, hold it up like this. So then we'll capture the next image. (0.15), not bad. Next. I'm not going to finish it here, but you get the idea. The first one is usually the most time consuming, but once you get the first one right, I think Lightburn becomes a little bit, so this one on the first try, we got it no problem. But it's really the first one that you got to make sure you get a good number. If you accept the result of, let's say, like 0.9 on the first try, then it's going to throw Lightburn off for all the subsequent, I guess, calculations it has to do. So now, we're kind of getting a good result on each one. We're going to capture again. 0.06. Okay, so it's going pretty well. But I'm still not going to finish it. I'll close it here. Okay, I'm gonna turn off my screen share. So I guess the takeaway from there is you gotta print the polka dot on and then tape it onto a very flat surface, and then you have to hold it up to the camera and not place it on the machine bed. The other takeaway is the first image is critical. You want to make sure you get a really low number in Lightburn, so patience with the first one pays off for the rest of the calibration and the calibration result as a whole. But I guess the biggest takeaway with lens calibration is it's not recommended. I think the factory setting, we have tried many times to beat our original factory settings, and we actually have never found, otherwise I would be uploading a different file to Facebook today. But yeah, the original settings were pretty good, but I think it's still possible that for certain cameras on certain machines, maybe a user effort would improve the results. So that's that. I think we can move on. Mm-hmm. So the last thing we want to talk about is common camera setup issues. And this one, I can quickly go over these, Dimitri?
Yeah.
Okay. So just whenever people plug in their camera and they don't see the result, they don't see an image, they just see a black screen, or they see the camera working fine in their native camera app in Windows, typically Windows. This is only for Windows, actually. But then they don't see it in Lightburn, so issues like this. So if you're using a Windows 7 and Windows 8, maybe also Windows 10, you said?
Yeah. On a home, Windows 10 on a home.
Okay, that makes sense. You have to install the UVC driver. So UVC is just a common video protocol for the camera. And I believe it was one of our users that queued us onto this. I believe it was Carlos.
That was Carlos, yeah. Carlos Patterson. Shout out.
Okay. Yeah. So we were stuck for a little bit, but we can. There's a Google Drive link, I think put up by the Lightburn guys, so we can post that in the group as well. So that's a common pitfall. If you see a black screen, that's most likely on Windows. That's most likely the fix. The next one is granting camera Lightburn permissions to access the camera. This is with newer installs of Windows, I think Windows 11. and you just have to go into settings, security, or security and privacy, and then you have to give Lightburn permission to access the camera. And the way you test this is, if you plug in the camera and you get a result in the native Windows camera app, but not in Lightburn, this is most likely the issue. The third one is just Lightburn can't grab the camera if another app is using it. So if you have another app open, just close it, and that should solve the issue. So those are the three. I don't think we have ever had a situation where the camera was actually broken, because we do test it at the factory. But of course, if it does turn out to be the camera itself, like a hardware problem, we can send a replacement. So that's that. I think that's all we had. I'm just going to go into chat and see if anybody has any questions.
So Scott says, so we don't really have to calibrate the camera. Not necessarily, no. With the file that we've already posted on Facebook, you just go through the calibration basically, and the alignment. I'm sorry, the alignment, not calibration, and you'll be okay. So every material thickness needs to be aligned. So if you're going to work on 3 millimeter, 1/8 of an inch, 1/4 inch, 1/2 inch, all these different steps in thicknesses, you got to make a new profile basically for every thickness for your camera.
Yeah. Laszlo said, I tried the lens calibration. I think that's what he meant, and it was a pain in the butt.
Yeah.
yes, it is. Yeah, so not recommended in most situations.
Yeah, it's the second time he's also asking about the 20 watt, by the way.
Oh yeah. So the 20 watt, we are going to ship it the week after next week, if not next week. So we have all the parts. We just have to assemble it. And once we ship it, we'll open. We'll do a pre-order, and we'll have it open for the first week to existing LaserMATIC10 customers only. And then in around, I think, the beginning of October, first week of October or the end of September, it'll be available just for purchase.
So we got this question over here right now. Cutting edge. You pick your thickness when starting the test. Yes, we do. Thank you, Nancy.
I think that's about it. If chucked rotary, yes, it will have a chucked rotary. The 20 watt will have a chucked rotary. And the chucked rotary will also be available like for purchase as a separate item. As also the 20 watt module will be available as a separate item also. Okay, I think that's about it. So thanks, Laszlo. Yeah, thank you guys for joining. Sorry for the technical difficulties. Cutting edge laser engraving. So how do I fix my camera issue? I think I can probably help you if we do, like if I know the situation a bit more in depth. So if you send me an email, or if I go back to your email, and maybe if we do a Zoom call, I think that would probably be helpful. Okay, all right. Thanks, guys. I think we can log off now. What do you think?
Very good.
Okay.
Thank you very much, people. Be well and be safe.